Hello everyone, I am Ananya Kumari of MTech IT 5th semester, and in this video I will be solving the second internal question paper of data science, which was in MCQ format. So let's just begin. In the first slide we have 8 questions, starting with the first one. It is, which paradigm of data research involves asking what problems can be solved with given data? The answer to this question is data driven. So when we have a data set and we make inquiries with it, and we analyze patterns, underlying insights, we get to know what are the assets of these data, what problems can be solved with it, and hence this is called the data driven. And unstructured data cannot be easily stored in relational database. This is why, because unstructured data are what unstructured data is what kind of data? Image, audio, video, mainly blob. So image, audio, video doesn't have a standardized format that if it is stored in this format, all of this kind of data will be stored in this format. And in relational database, every column has a predefined data type that is strictly followed. Hence it becomes difficult to store such kind of data in relational database, as the formats of data to be stored can be varied. The probability of an event E is calculated as the sum of probabilities of outcome in E. In descriptive statistics, which measure is useful for skewed distribution or data with outliers? So if we have data that has outliers, for the measure of centrality we cannot rely on mean or geometric mean, as they are prone to the presence of outliers. It manipulates the value of mean and gives us a wrong idea. So we do not use these two options, and mode doesn't have so much association, or you can say relation, with centrality. However, it is not affected with the presence of outliers. Still, median is the best choice in this scenario, as take any formula for calculating median. uh, it doesn't rely on the presence of outlier, or is not affected that way. During data cleaning, artifacts are systematic problems that can be corrected if detected. Feature engineering for discrete data includes one hot encoding. So feature engineering is about create since suppose if we have some features, then we evaluate these features to the type of feature that leads to even better outcomes, and it becomes simpler for the algorithm to work on these data. And in one hot encoding, we suppose we have a categorical data, we have a column of a place. In this we have options like Patna, Indore, Bhopal. So ML algorithm finds it difficult, cannot work on these kind of data. And if we provide any sort of number to these data, it can lead to other problems, like assuming priority of that data based on value of numbers. So in one hot encoding, we just calculate the number of features and add that much column to the real data set, and for every row we add one to that column that is present in that row, and for others we insert 0. In the normal distribution follows 68, 95 and 99.7 rule. This is called empirical rule, in which 68% of the data lies within 1 sigma variance, 95% lies within 2 sigma, and 99.7% lies within 3 sigma. In modeling, the error E consists of reducible and irreducible error. In modeling, we have both kinds of error. Reducible error can be reduced using different kind of model, and irreducible error cannot be reduced. Moving towards the next slide, we have questions, in which the first one is, Occam razor suggests choosing the simplest model with equal performance. Here Occam razor was ML philosophy, in which if we have a number of models having the same kind of performance, then we choose the simplest one. Parametric model risk wrong assumption leading to bad result. This is why, because parametric models assumes a function, form or shape and work on that. But if those assumption goes wrong, it can lead to bad results. For question 11, for classification evaluation, precision is TP divided by TP plus FP, which is the measure of correct positive out of all the positive predicted. How much we are correct here. In linear regression, coefficients are found using minimizing RSS. Obviously, we uh, keep minimizing the distance between points so that we could select the most suitable answer. In logistic regression, we don't predict numerical values, we predict discrete values that can be 0, 1 or true or false. It uses sigmoid function. We check the probability of an event, whether it is gonna happen or not gonna happen. Euclidean distance in Minkowski with k is equal to 2. Here the value of k will be 2, which is used for calculating distance between 2 points in space, used widely in ML algorithms. K means clustering assigns observation to the closest centroid. In K means clustering, we randomly select centroids and assigns the nearby points to the nearest centroid, and we keep repeating these steps until the assignment of points become identical, or you can say there's not much changes. Decision trees are prone to overfitting. This is done when the ML algorithm is trained on trained data and fails to predict value for unseen data, and decision trees are prone to those. In neural network, activation functions include non-linearity. Here in neural network, the activation function since introduces non-linearity, this helps the neural network to predict the non-linear relationships and work in a better form. Hadoop's HDFS provides high throughput. Here, why is it not marked? I don't know, but here I guess Hadoop's HDFS provides high throughput data access. The option B is correct. Here we can store data, big data, in a distributed system which provides high throughput data access. We can access data and handle and manipulate, performs all sort of operation very easily without relying on the same or single system. In SQL, to combine rows from two tables based on related columns, we use joins. Join the table based on the related columns. Python's DQ support, here the option B is correct. Pop and append from the both ends. Q, we know that the Q is used for implementing the FIFO operation, but if it is a DQ, we can insert and remove data from both ends. The following types of data mentioned in data sciences: structured, unstructured, and quantitative and categorical. All kinds of data are there in data science. Moving to the next question, 22. The following probability concepts: independent events, Bayes theorem, expected value, variance. Variance is not equal to sigma. Variance is not, this is not a probability concept, only the upper three of them is. So option A is correct, which is JKL. Now 23. The following are the data cleaning methods for missing value. So if we are inserting a value in a row where there are missing values for a specific column, we can use these three options: drop the records, which is not recommended, never; mean value imputation, here it can be used; and nearest neighbor, not outlier detection, it is not, how actually it is. Now moving towards the next slide, which is 24th question. It's the following are modeling philosophies: Occam razor, simplest explanation; bias variance trade-off. Occam razor, which means we have a number of ML algorithms that produce the same result, then we choose the simplest one. Bias variance trade-off is that no model is the best. We use a combination. Actually, it's not that. It was no lunch theorem, no free lunch theorem. That no model is the best. We use a combination of many, so to get the desired result. Bias variance trade-off means in a model there has to be low variance and low bias. If a model is overfitted, there will be high variance. It will not do well on unseen data. If a model is underfitted, then it will have high bias. It will not perform good on seen data and well as unseen data, that is the test data and the training data. Nate Silver, think probabilistic. All these are modeling philosophies, so option A is correct. The following are distance measure: Manhattan k is equal to 1, Euclidean k is equal to 2, cosine for vector, and KL divergence for probabilities. All these options are correct. So distance measures helps calculating the distance between 2 points in space, and all these things are used for doing so. Moving towards the next question, we have a table in which there are options given, and here option A is correct because um, normal distribution is a bell-shaped distribution and it is symmetrical. So for B the answer is 2, for A the answer is 1, which is expected value is equal to MP and variance is equal to NPQ, where P is the number, P is the probability of an event happening and Q is of not happening, which is 1 minus P. N is the number of trials. For Poisson, we have 3, expected value is equal to variance is equal to lambda. Power law means it has long tails, right? So option A is correct. Moving towards the next question, which is question 27. So here we can see that option A is correct, since reducible error can be minimized by better technique. Irreducible error cannot be minimized. Overfitting means high variance, model noise. Underfitting means high bias, misrelations. In question 22, linear regression predicts numerical value, minimizes RSS. Logistic regression predicts a probabilistic value 0 or 1 or true or false using sigmoid function. K-means algorithm involves clustering and centroid. Decision tree binary branching prone to overfitting. In the next question 29, we have HDFS, which is a distributed file system. MapReduce helps with parallel processing, and Yarn is more about job scheduling and resource management. It allocates resources to the server, nodes in the server. Spark is associated with in-memory processing using RDDs. Moving to the next question, which is Question 30. Correlation doesn't imply caution. It measures the degree of relationship between, but not the cause effect. Option A is correct because both are true and both explains each other very well. Correlation uh, eh, observes associativity, how data are associated, not the causativity. Association and causation are not the same. 31. Gradient descendant use learning rate for step size. It minimizes cost in linear regression. Both are true and both explains each other very well because linear in gradient descendant, the alpha predicts the next value and hence it minimizes the cost in linear regression and gives better performance. Neural network are universal approximator. They can approximate any complex function with enough layers. Neural networks are indeed called universal approximator. They can actually approximate any complex function if it has at least one hidden layer. And mm, and yeah, actually since it has at least one hidden layer and an activation function, it helps it to, you know, do approximation for any complex function. Moving towards the 33 question, in which SQL in SQL join combines row based on related columns. It handles data from multiple tables. True. It hand he, these two options explains each other very well. Joins actually handles the data from multiple tables and combines it using related columns. Moving towards the 8th slide, we have the first question is arrange the steps in k-fold CV in the correct order. So k-fold cross validation, in this we have suppose our data is divided into k parts or k folds. Here one data set or part of data is used for the testing validation actually, or other k minus 1 is used for training, and this is repeated for k times, using choosing that one data randomly and uniquely. That one data which is chosen at random and it has to be unique than chosen before. So by this we validate on almost all kinds of data and we get to train on almost all the parts of data, so it leads to better results. So here first we divide it to k folds, train on k minus 1 and validate on 1, repeat k times and then calculate the average. So option A is correct. Arrange the gradient descendant algorithm in the correct order. So in gradient descendant actually we first compute. Here actually we first choose the learning rate, what should be the value of alpha, then we calculate the gradient with it so that it reduces the cost. Then we update the parameter and repeat until conversions happen. Arrange the k-means steps in the correct order, which is question 36. So in k-means we first at random choose points as centroid, then we assign nearby points to the closest centroid, then we again calculate centroids based on the mean of the chosen one, and to the new centroids all the nearby points are again assigned to the closest centroids, and this is repeated until the assignment of centroid becomes identical, or you can say there are very minimum changes. So option B is correct, which is random initial assignment, then assign to closest centroid, then compute new centroid, and iterate until no change. Arrange the map reduce process in correct order. So in map reduce, we first process data to key value pairs, then shuffle and sort, then reduce to aggregate, or you can say lowest value, and then output the result. Option A is correct. Moving towards the last slide, including questions, we have question 38, in which in neural network training we need to arrange this. For neural network training, how this happens. So first we do forward propagation, then we compute the loss, then we do backward propagation and update the weights. So this is how all these happen. Arrange the PCA steps in correct order. So here the correct order will be, we first standardize the data, then we compute covariance matrix. After that we find eigenvectors, and finally we project the data. So option A is correct. Arrange Hadoop components in data flow in correct order. So first thing that happens, the data has to be stored in HDFS storage. After that happens yarn scheduling, what system is going to perform what, and map reduce processing for output, then output is sent to HDFS system. So option A is correct. Lastly, I would like to thank you all for giving so much time to this video. Thank you so much.